when we see a problem like this, right behind you, just a second, Alma. We are used to, when we see a problem like that, just typing it in our calculator. So what would we wish we could type into our calculator for number 3?
Wrong number 3.
Right on the review sheet, problem number 3. 18C3. So what you would want to type in is 18C3, right? Now, what if you don't have a calculator? Then you have to be able to figure this out, right? Which means you got to remember your little formula, which is not on the reference sheet. So what do we do? So 18 factorial over 15 factorial, 3 factorial. So without a calculator, this is not bad. We have 18, 17, 16, right? And then after that, that's all gone. And then we have 3, 2, 1 on the bottom. Now you can handle that however you want. I would probably myself say, okay, that's 6, so that's gonna make that a 3. And then I would have to multiply 17 times 16 times 3. Or 3 times 17 is 51 times 16. However you want to multiply that. But be prepared to have to be able to use your formulas for your combinations and permutations. What would be different if this were this? There would be no 3 factorial, so that would be actually even more multiplication, right? And what would the problem, let's keep the numbers the same, 18 and 3. What would what's some way the problem would have looked to get that problem, or to get that answer?
You're choosing students to play a role
in the school play or something, right? So how many ways can I pick the Scarecrow, the Wizard of Oz, and Dorothy, right? That would be it right there, 18P3. Okay, all right, so that, I just thought of that. Okay, now what else have you thought of as you have been preparing diligently?
Will we get our test back today?
Yes, we can get our tests back today. They are graded. I've already taken it and they're graded, so we'll do that. We got a couple things we want to do, but I want to get some review in first. Yes, Catherine?
Can you do
18. All right, so given that cosine theta is negative 5/13, theta is between 0 and pi, find tan 2 theta. Now, that's going to be a formula. You're going to need the identity for tan 2 theta. It is on your sheet, so you will find that. It's 2 tan over 1 minus tan squared. But in order to use the formula, you're going to have to figure out what the tangent is. So let's look back at the given. Cosine is negative. Where does that happen, that the cosine is a negative number? Yep, Don's going like this, over here, right? This is where cosine is negative, because cosine is x. Now, I am limited, though, by the problem to being between 0 and basically 180, 0 and pi. So if my options for negative cosine are all of this, but I am limited to be between 0 and pi, then what quadrant do I have to be in? 2, gotta be in quadrant 2. So I'll draw my angle, my butterfly bow tie in quadrant 2. Cosine is adjacent over hypotenuse. You might recognize those numbers, but if you don't, you'll do the Pythagorean theorem to figure it out. That is a Pythagorean triple, so this is 12, positive. So what's the tangent of that angle? This is a picture of the angle, straight from the given. What is the tangent of that angle? 12 over negative 5. So I'll plug that into my formula. So 2 times 12 over negative 5 over 1 minus 12 over negative 5 squared. So draw a picture of the given, get the numbers from the picture and plug them straight into whatever formula you're using. So this is negative 24 over 5. This is 1 minus 144 over 25. Be careful with this arithmetic. I see a double negative, but they don't cancel because that one is getting squared. So that stays 1 minus. I'm gonna times everything by 25, but you can clean this up however you want. So I've got negative 120 over 25 minus 144. I got 120 over 119 as my final answer if I did my arithmetic correctly. Okay, now, on the exam, it may not be tan 2 theta, it might be cosine 2 theta. No big deal, right? It's just a different formula. You're gonna plug your numbers into a different formula.
Can you do 8?
8. Find the determinant. How do we find the determinant? This is a 3 by 3. How do we find the determinant of a 3 by 3? What do we do? So the first 2 columns, exactly as they are. Don't mess with them. Don't change anything. Just cut, paste, and then start right here where my pen is and multiply. Negative 9. Multiply. 5 multiply 0. Total them up. Looks like so far I've got negative 4. Right? Then what do I do? Other way around. So multiply, get 75, 0, and another 0. So that is 75. Then how do I get my answer? What do I do with those 2 numbers? Subtract. So negative 4 minus 75, negative 79 is my answer. Okay? What else have you found that we need to look at?
For 5, what are the classical curves?
Oh, who can tell her? What are the classical curves? What? We got spirals. Spirals are one of the classical curves. Limousin, lemniscate, and the rose. Yep. So you'll just, I don't want to spend a lot of time on that. That's vocabulary. Go back to your chapter 6 notes. Yeah, 6. Like 6-4, 6-5, somewhere in there, and study those notes. Okay? Because you not only need to, you need to be familiar with them, not only the name, but what is their shape? What does the equation look like? Not anything hugely complicated, but in general, yeah, you need to know those. Yeah.
We have to know the family of functions.
The BFFs.
Yeah.
Yeah, the BFFs were out of chapter 1. Now, the BFFs have followed us, because one of the BFFs, all the trig function, well, sine and cosine are BFFs.
There's only semester 2 stuff.
Huh?
There's only semester 2 stuff.
Yes, this is a semester 2 exam. So you're only responsible for the BFFs if those functions have been covered in this semester. Okay, so I'm not gonna say which of the BFFs is decreasing on its domain. No, I'm not gonna do that. That was chapter, that was semester 1. 7 is find the inverse of the matrix. How do we find an inverse of a matrix? So we need to do some switching around, so we'll switch those two. And these two change their signs, so that's part of the problem, but we're not done yet, right? We're not done with that, because why? We still need to evaluate the determinant. So go back here, the determinant is 1 times 7, 5 times 2, and subtract. So 7 minus 10, so the determinant is -3. And then we take that -3 and we divide all these things by it, and then we simplify. So it looks like -7/3, +2/3, +5/3, and -1/3. No, not a hard problem, you just have to know what the procedure is. Okay?
So if you multiply both of those together, would you get the identity?
Yep, you better. And matrix multiplication in general is not commutative, but with inverses it is. So it wouldn't matter if you took A times A inverse or A inverse times A. You should get identity both ways. Okay, what else? Yep,
31.
30. Okay, so let's look at what we've been given here. First of all of your sequence and series formulas are on the reference sheet. So this says an arithmetic sequence. So my i's are gonna zero right in on that formula. That is my arithmetic sequence formula. And it tells me that the first term is 17, and the 17th term is 65, and my job is to find the 123rd term. Okay? So let's talk about what we know right here. If we let n be 17, we know let n be anything we want, that's a whole number. If we let n be 17, then can we say 65 equals 17 plus d times 16? Take a look at your formula. That's 17, right? I have no idea what d is. But if I'm letting n be 17, then n minus 1 would be 16? And what am I figuring out here? D? So D is 3. Perfect, 3. So if D is 3, then I can find my 123rd term, because my 123rd term, same formula, is my first term plus D times 122. And that'll be it. Okay? Someone?
Yeah, would you still be able to do that, like if they give you the second term?
Yep.
Okay.
Now, if they gave me the second term and told me it was arithmetic, then it would automatically know D. I wouldn't need to do all this, because if I had first and second, then I know what D is. Right, Sammy? Yeah. Okay, Kylie?
Can we do 26, please?
26, yeah. We don't have to do anything here, we just need to look at it. We're gonna talk about a couple of these when I return your test. What's the limit in number 26? Look at it, guys. What's going through your brain? What's going through your brain is, what's the highest power in the problem? Highest power in the problem is n squared. How many do you have on top? 5. How many do you have on the bottom? Whoops! 5 over 0 doesn't work. So what's the limit? There isn't one. It's divergent, no limit, empty set, because you can't divide by 0. And if you think about it, if the top of the fraction is n squared, and the bottom of the fraction is just n, as n goes to infinity, they're both getting big, right? But isn't n squared getting way bigger and way faster? So there isn't a cap. It's just exploding. Now reverse sum, and then the limit would be 0, because then you'd have 0 over 5, which is 0. Okay? Got it? I can't tell. You're just
Yeah.
smiling and nodding. Okay. All right, good. Smiling and nodding's good. All right. What else? What else do we need to look at?
Can I do 20?
20. Find the coefficient. Okay, this is a no calculator problem too, and we're kind of used to using our calculators here. Find the coefficient of the fourth term. Let's see if this is a mistake or if I can really do this without a calculator. I want to find the coefficient of the fourth term. Okay? So, in a 10th expansion to the 10th power, there's 11 terms in that expansion. All of them have a coefficient. Where do the coefficients come from? If I were to write out all 11 of those terms, where do the coefficients come from? Either Pascal's triangle, which you would have to build down to the 10th row, or where else can I get them? 10C10, 10C9, 10C8, 10C7. So I'm going to go that route rather than building the whole triangle. Either one will work. So the first term is 10C10, 9, 8, 7. So the fourth term, which is the one I want, is 10C7. Now, I don't have a calculator, so I'm going to do what I did a minute ago. I'm going to go ahead and figure out what that is using my combination formula. So 10, 9, 8 over 3, 2, 1. That's pretty easy multiplication. That's 120. Now, if you build Pascal's triangle, then you're just going to see 120 right there. It's just going to be there. Here I had to figure it out. Okay, are you with me so far? Next to this guy is going to be an x and a negative 2y. Now, I know the question says, what's the coefficient? But this is going to play into that, right? If this weren't there, 120 would be the answer, but that is going to become part of the coefficient. I still need to figure out my exponents. So remember, if you wrote the whole thing out, the first term would be x to the 10th, 9th, 8th, 7th. So this is a 7. And if that's a 7, this will be a 3. So my coefficient is going to be 120 times negative 8. So negative 960, x to the 7th y cubed. So yeah, that was manageable without a calculator. Now, this is the whole term. The coefficient would just be negative 960. Okay? For me? Thank you, Sam.
Thank you.
We're getting ready to take our exam
Uh-oh.
that you took last year.
Uh-oh.
Uh-oh. All right. Good? All right, what else? Let's do a couple more, then I want to pass back your tests and go over a couple things there. A couple more questions. Liam's not here. He wanted to ask some from the other review sheets. I'm fine with that at this point. We've done almost everything on here. I want to keep us focused on this stuff. But if there are some things on the other review sheets, wanna look at. We can do that too. Neely, review number 2, question number 3. Review number 2, question number 3. Well, you should know this, it isn't on your exam because it's out of chapter 3, and you were past chapter 3, when you got to this school, but you should know that. Does it represent growth or decay? That is a growth, because 1.07 is bigger than 1, ties into limits, exactly. If that number is 1.07, aren't we getting bigger? And then what's the percent growth or decay? 7%. How much bigger than 1 am I? And then what is the initial value? 20. That formula, that format is always describing something growing or shrinking. So population or bank account or something. So whatever it was, I started with $20, 20 people, whatever. That is not on your exam though, because it's out of chapter 3.
Can you do 1C on this exam?
On what?
The same exam, or review?
Same thing, 1C is a simplification. You guys we spent time doing all of our identities, verifying and simplifying. You guys need to be able to do this. Whoops, that's a square. So what's your thought?
Take that as 3.
Well, we absolutely could take out a 3 and cancel it. Yeah, we can do that. So that's cosine squared over 3 minus 3 sine. Remember, you have to factor it out. So I factored out a 3 and then canceled it. That's fine, perfect. There's more to it than that. What else do I need to do?
Cosine squared is 1 minus sine.
Yes, indeed. Cosine squared is 1 minus sine squared. And what do I notice about 1 minus sine squared?
You can crop cap.
You can factor. It's the difference of squares.
You can take that as 3.
And then we can pull that leftover 3 out of here, and oh my gosh! So we had to simplify it, and it simplifies to 1 plus sine over 3. Probably, I'm glad whoever asked that question, I'm glad you asked that, because you probably need to practice a little bit of that.
Can you do 14?
On that same paper,
Oh yeah.
14 says consider this function. You're not graphing it, although we could. We are just figuring out all of its characteristics. So you can graph it. So what's the amplitude of this curve? Amplitude's 3, absolutely. There it is. That's how high my hills go and my valleys go down. What's my period? Finley? Thank you for keeping your eyes open. Are you feeling okay?
Yeah.
Yeah. You know, when you fall asleep, it hurts my self-esteem. All right. What's my period supposed to be for a cosine? 2 pi? For a cosine and sine, the period's 2 pi. What has this done to that? Divided it by a half, which means my new period is 4 pi. What's my phase shift? That's your horizontal shift. What is it? Negative pi over 4, or some people say left pi over 4. It means that instead of starting at the origin, your picture is going to be shifted pi over 4 to the left. And then what's my vertical shift? Up 2. Up 2 or positive 2.
Do you not have to distribute the 1/2?
You don't want to ever distribute the 1/2. You want it out of the parentheses. Yeah. You can't find your phase shift without that, without getting it out. So you don't know, you do not want to ever distribute that. Tess? You decided to order a new Buick, you choose from 8 standard, how many different cars are possible? 8 times 5 times 4, period. I go in, I have to pick a color, I have 8 choices. Yellow. Then I have to pick another color, I have 5 choices. Green. And then I have to pick tires. I don't know anything about tires. 14-inch, I don't know. Done, right? I have 8 times 5 times 4, that's it. Notice there are no factorials in that problem, because I'm not arranging anything. How many ways can I arrange 8 books on a shelf? 8 factorial. Am I arranging these colors? I'm picking. Shirts and jumpers, exact same problem. Okay, what else? One more, and then I'm gonna hand some stuff out. One more. Yep, Tilly,
I think it was 8 on the
same
same packet.
packet. Number 8. Partial fractions. So how do we start this? Remember what you're trying to do is take this big fraction and you're trying to break it down into a couple of smaller fractions. So what's the first thing we do when we see this problem? Yes?
Factor the bottom.
We factor the bottom. Because we're gonna try, make sure you factor correctly, by the way. We're gonna try to figure out what the denominators of these 2 fractions are first. And the denominators are just gonna be these 2 factors. If you think about it, if I said add these 2 together, wouldn't that be the common denominator? Yeah. Now, I have no idea what's on the top, and you don't either, so we're just gonna call it A and B. Now what? Clear all the fractions out. So I'm gonna multiply through by this. So when I do that, and you don't have to write it down, you guys are smart enough, you can do this in your head, but I'm gonna write it down because I want you to see what's happening. When you multiply through by the common denominator, it literally removes the denominators, which is your goal. Then I'm just gonna go ahead and do some basic distributive stuff. Now, this is an equation, right? So however many x's are on this side have to be the same as the x's on this side. So on this side, I have 1x. On this side, I have a plus b. So I don't know what a and b are, but they have to add up to 1. Does that make sense to you, Zoe? Because they're combining to give me x. And then the things without x's, 2, have to match the things without x's on the other side. So whatever these are, when I add them, I have to get positive 2. So what have I got here? System of equations that you'll solve however you want to solve it. I'll just multiply the top one by 2. So I'll have 2 equals 2a plus 2b. So it looks like 4 equals negative b. So b must be 4 if I added right.
Negative 4.
Oh, yeah, negative 4, thank you. Yeah, thank you. That would be bad, thank you. So b is negative 4. which means that A must be 5. And then the answer to the question, go back to the beginning and write the fraction. That was your job. What are the fractions? So A, 5 over x minus 3 plus negative 4 over x minus 2. Those are the partial fractions. Okay? All right, now I'm gonna hand back your test while I'm doing that. Would you get out your iPad, please? Go to Schoology.